Okay, so the next set of injection is SQL injection. So I'm going to first start with the motivation. So SQL injection, and this is actually quite an old vulnerability. I'm not sure how much longer I'm going to be teaching this, but until we get rid of all the old SQL, I think I've got some material for a while. But you'll see that some of these examples are old. It's rare to see some large-scale SQL injection exploit in the wild. I read the news a lot. And so SQL injection, it has been lucrative though. So there's this great article on how this person with very little training figured out what a SQL injection was and weaponized it. And this was about 15 years ago. So there's this link here that if you click on it, it's a fascinating expose on this guy and how he got like 180 million credit card numbers using this one thing, SQL injection. And so the guy's name is Albert Gonzalez, and well, it's 150 in this, but I think they actually underestimated how much he actually got. And his attack vector of choice was SQL injection. So it's a lucrative exploit. It's impactful. So here is an account of 32 million accounts being exposed using a SQL injection attack. And so it was a SQL injection flaw, and basically 32 million records were exposed. And what's worse about this one is that not only were they exposed, they exposed the plain text password. So this is a double bad thing, because typically it's bad enough you have SQL injection, but it's worse that you're storing the user's passwords in plain text. We'll get to the way you're supposed to store passwords next week, but both are no-nos. SQL injection is ironic. So mysql.com was actually hacked with a SQL injection a while back. And as the double whammy on that, as part of the injection, it exposed the director of product management's WordPress password as being a 4-digit number. And they were surmising that that might have been his bank card PIN number too. And then the last part is SQL injection is funny. So this is the famous XKCD cartoon that if you don't show, something's wrong with you when you're teaching SQL injection. But the way this works is that you have a mom who's upset at the school and decides to name her kid Robert, and then with the last name of single quote, parentheses, semicolon, drop table students. And this will all make sense to you after we talk about this particular thing. And what this is doing is it's injecting into the SQL interpreter. So again, breaking syntax of SQL with the single quote, injecting a command, so it's got the semicolon. So like, oh, I'm done with that SQL command. I need to execute another SQL command. And it's just say drop table, drop the student table. And then the school is mad at her. And then she's like, I hope you learned your lesson, to sanitize those things. The other funny thing is this thing. So if you look at this and get a handle of what it actually is showing you, what do you think? So this thing, this list of companies, and company number 10,542,519 is named semicolon drop table companies semicolon dash dash limited. So yeah, a SQL injection attack is a legal company name. So this is probably someone who was tired of having to find SQL injections and just decided for all the companies out there who still have this, I'm just going to name my company this, and then if you have this on your site, I'm gonna give you a message and delete your, yeah. So it's very creative actually. So, and then I love the comment, little Bobby Tables. Bobby Tables is the other cartoon. Bobby Tables is all grown up, has his own company. Okay, so I'm going to try and teach you how this exploit works. The way you do this exploitation could come, again, just like with the command and the code injection, it can show up in a number of different ways. And so when I talk to you about different ways of doing this exploitation, it's going to be organic. When you come across an injection, it'll be similar. You'll try and fuzz it with a bunch of characters, and then you'll try and use, it's like problem solving. there's usually not one string that'll work on every single SQL statement, but it depends on how the SQL statement is implemented, and you have to debug that in order to figure out a SQL injection payload that's actually going to get you what you want. Okay, so it's actually a sequence of things that you have to do to actually exploit SQL. So the first thing is, what does SQL stand for? This is called the Structured Query Language, and it is used to interact with the relational database backend. So typically on all the backends of websites, you have a SQL database storing all the user information. And the SQL is the language that the web application is going to use to query the database in order to get the records to and from the database. So both storing and retrieving data is done through SQL. The commands that you'll need for this particular class are create and drop. Creates a table or a database, and then drops a table or a database. And then the select and the where clause. And these are ways of querying the table. And this is the main SQL that you'll need to know, but I'll add on some other SQL commands that are helpful in the injections. So here's an example of a relational table. The table is called users, which is what this denotes. This table has columns, ID, username, password, and isadmin. And then in this table, there are 2 rows. So that means there are 2 users in this user table with username Bob and Alice and IDs of 1 and 2. So that's so what select and where will do is it will form a query against this table that will then produce some kind of data as a result. And it's basically a programming language to ask the database for certain kinds of data, and then the result comes back. Okay. So here's an example of how it would be used to log into a website using SQL. So on the server, so this might be your PHP or your Python or your Java Node.js code. There's a SQL statement that says select the password and whether or not the person's an administrator from users, where the username is some parameter that is going to be pulled from the web app. Okay. So the user is gets a login form, and as part of the login form, it has a username field and a password field. The username is Alice. The password is secure with a 3. And this gets sent to the web app, and the web app is going to look at this username field and say, oh, the user that's trying to log in is Alice, and the user supplied password is secure, but I need to make sure that this password matches the password, and I don't know this here as the web app. I need to make sure that this is the stored password for this particular user. And so what I'm going to do is I'm going to substitute that question mark for Alice, generate this query, and then send it to the backend database. And the database is going to parse this query string. So it's just a string that the web app is going to send to the database. So here is here's the select statement. Select the password isadmin from users where the username is Alice. So this is what the parsing will do. It'll first invoke the first part of it, select password and isadmin from users. And what that will do is it will take the password, the isadmin from the users, and it will return as a subresult this thing. And this is all running on the database server. It's not going to return it to the user. But then you can't see that. Hang on a second. Turn the lights down. So the light blue is what's the part of the table that's selected. And then the next part is where the username is Alice. And so it'll go down, it'll go to the username column. We'll find a row that has Alice, and then we'll return just that row. So secure and false. And the database will then pass this back, right? So the web server sent that query. The database server is going to send this row back to the web server that's got the password and the isadmin is false. And so that is what the picture looks like. Now this result gets returned to the server. And the server is going to take the password supplied by Alice, which was secure, compare it to the password in the database, which is also secure, should be actually password hashes that you're doing here, just as a note, but we haven't gotten to the password storage thing yet. So this is just an example. This is not something that you should actually build in terms of password comparison. But yeah, we're assuming plain text passwords are stored in the database, which is a bad assumption, but in this particular case is what is being done. Then you've got the two passwords, you do a comparison, and then you see that they're the same, the login is successful, and then no admin privileges are given. Okay, so that's the way it should work for you to log in. And then maybe you can issue a cookie for Alice, and then you'd be able to, so you don't have to repeat this authentication over and over again, you would issue some authorization cookie or session cookie to keep this thing going. Okay, so the perfect password is this password. X, capital X, single quote, or 1=1 with 2 dashes. And the reason why this is perfect is it's got an uppercase letter in it, it's got a lowercase letter in it, it's got a number, it's got a special character, and it's 16 characters long, right? So that meets just about every metric for a password. Not only that, it's got this extra feature that it logs you into all sorts of other things that you probably shouldn't be logging into, but it'll give you access to anyway. And so how does this exploit work? So the way this works is basically you're going to have some login form. So in this case, it's rather than usernames and passwords, it's accounts and SKU numbers. The way it works at the highest level is that the application is presented, the form is presented. You submit this naughty string to the web server. And then what the web server does is it submits the query using this account name. And so this query is, as we saw before, select star from accounts where the account is this. So this breaks the syntax of the SQL statement, and this executes in the SQL context, or 1=1, and then this is the comment character in SQL. And what this does is that rather than selecting a single account, this thing will return. This will execute on the database. This will return on the backend database all of the accounts, because the 1=1 will say, oh, you need all the rows, right? Whereas that where statement was trying to filter out to a particular account, the 1=1 will return the whole thing. And then this is how the adversary will exfiltrate all of the account numbers from that backend database. So that's an animation. We'll get into a little bit more of the details. So again, this is the example that we started with Alice and the password secure. So instead of Alice, if we do if we break the syntax and we send this predicate 1=1 there, and you'll note this is a little differently formed. So with this single quote, I break the syntax of this statement, and then on the other side, you see I have an open single quote, so to fix this SQL statement back up. So this allows me to make sure that if the single quote breaks the SQL statement, that I have fixed up this thing by having an even number of single quotes that I inject. So what's going to happen here is this is the SQL statement. When I inject this 1=1, this is what gets filled in. So look at this syntax closely. I've broken this syntax with that first red quote, and then I have in SQL or 1=1, and then that last quote, which was from the original SQL statement, that fixes up the final one in that statement. So this is what gets passed to the SQL interpreter, and rather than so this is what gets executed on the SQL interpreter. So the first thing is the same. So you get select password is_admin from users. The thing that the where statement, it says where username is equal to 1. Now, if you look at this first half of this statement, there is no username that is equal to 1. We have a username of Alice and the username of Bob. So what this does on the back end is it deselects everything. But then when you do the next part of this SQL statement, or 1=1, it reselects the entire table. And this is where you get both of these things are then passed back. So rather than not having anything passed back, you get the whole table. Okay? Does that make sense? It's a canonical. This is like the basic SQL injection. So it's important that everyone understands this piece before we go to the harder stuff. Okay, so the exploit varies based on the implementation. And you're going to probe the form for characters until you break syntax. And the first things I would probe the form for are with single and double quotes. And if you inject a single quote or a double quote and you get an error message that looks like this, then you know you've broken the syntax of the backend SQL. If you actually get an error from the web interface that says, hey, look, there's a MySQL problem, then not only do you know the backend, if the thing is emitting an error message, you can actually see, hey, your username was a single quote, which is what this error statement is. So sending the single quote as a parameter and then seeing this error will not only reveal to you the actual SQL statement being run, but it'll actually show you where you're injecting into, the names of the fields that you're injecting into. Okay? So this, hopefully you never see, like it should never be this easy, but if you do see it this easy, run away from that company very quickly because it means that they're probably not going to be responsible with what you, the data that you give it. Okay, so with this error message, you can infer this query and that you had injected that red single quote into that query and that this is likely what the SQL statement is on the back end. And from here, then you can craft your injection that will get you what you want on the back end, or a sequence of injections to navigate the back end database to get you what you want. Are there questions about this? Okay. The other lesson that this teaches you is that if you are developing a web app, make sure you're sanitizing all of your error messages. Or make sure your error messages are going to a back-end system that's not accessible from, or is locked down in a way that only the right people can access it. So that's another. We'll get to that later on in this class. Okay, so here is an example PHP script with the vulnerability. It has a variable called SQL statement, which is a string. And you see this string is basically a template for you to fill in the values that are submitted from the form. So select star from users where username is equal to, and then you're going to quote this out for the SQL interpreter, the single quote, and you're going to pull the parameter from the web form, or from the web request, in this case is the get parameter, and you're going to fill in the username from there, and then the rest of the SQL statement is the and password is equal to, and then this is the password the user supplies. You build out that string, and then you send it to the backend database. And this is the way you send that string to the backend database. So if the user is foo and the password is bar, then the value that's passed to the MySQL query is what you would expect. This is what you want. This is what the application wanted. Okay. If you have supplied these two injected strings, again, single quotes for breaking syntax, and then to insert an always true statement for both the username and the password, then what gets passed to MySQL query is this string. And this string will basically, because both of these predicates, or 1 is equal to 1, and this or 1 equals to 1 are both true, this and will always be true, and this where statement is basically not going to be useful. You basically get all of the users with this query. So this will select out all of the users in that table. Okay, so if you are accessing a web app and it's hitting the database, and the database, because you have done this injection, is spitting out the entire user table, that actually might break the web app, right? The web app is probably only expecting 1 entry at most, or no entries. And if it's expecting exactly 1, then having the web app crash is not good for the adversary. So the other thing that SQL provides is this very convenient limit operator that says limit the results to a certain number. And so if you say limit 1 on this, you will just get the top one, which is good because this top one has the isAdmin as true, right? Like you can get arbitrary entry. Well, you can get the top entry when you do the limit 1. You can't. We'll talk about how you can order the results later, but this is what the limit statement will do when you add it. Another thing you can do is inject comments, and this is similar to the code injection, injecting comments. So again, this is our original SQL construction, the SQL statement. If you find that closing SQL syntax is a hassle, you can, so when you're injecting that exploit, the or 1 is equal to 1, you have to supply an even number of single quotes to patch up the syntax of that statement. You can also inject the comment character in SQL. Different SQLs have different comment characters. The two that you'll come across are the pound character, which will eliminate everything afterwards, and the double dash is another SQL comment sequence that will eliminate anything subsequently in that string. Here's an example where if on this select statement, if I use a username that has the or 1 is equal to 1, I break out a syntax with a single quote, and then I do or 1 is equal to 1, and then a pound character that comments it out, I don't have to reform syntax, because that other quote that I was trying to pair up with, that no longer gets executed as part of this SQL statement. Okay? So it doesn't even matter what I use for the password in this case, because the thing that's going to get generated is this. So now I have select star from users where username is this. I've broken out of syntax with this single quote. And then I have or 1 is equal to 1. This gets executed by the SQL interpreter, as does this hash. And then it means that the rest of this string basically doesn't get executed at all by the SQL interpreter. Okay, so then what you would get is this string is sent to the SQL backend, and this string on the SQL backend will translate into that, right? It'll end there. It's just something important because you'll be using the comment character throughout, and I just wanted you to see exactly what the use of it is doing to the SQL backend. Okay, the other thing is that if you are using the hash or the dash dash, some SQL interpreters require a space character after you use those two characters. There are some levels in your homework, I believe. There's a level in the homework that requires a space after the comment character. So adding spaces is no problem for an exploit. Okay, the next thing I want to talk about is the union operator. And this is a really handy thing for when you're trying to do an injection. So this is our original table again. A union will merge two tables together. So we'll talk about why this comes in handy. But there is a caveat. The tables have to have the exact same number of columns in order for them to be merged together. Okay? And you, a priori, have no idea how many columns there are in these tables that you're trying to exploit. Okay, so that is a problem. So if I do a select star from users, and the users table has 4 columns, if I try and do a union with select 1, 1, 1, and so when you use 1, 1, 1, it's actually going to insert those as real values. So what this tries to do is it takes your original user table and tries to append a row that's got integer 1, integer 1, integer 1 attached to it, and this is going to fail, right? 3 columns versus 4. But if I do this, 1, 1, 1, null, then if I do a select star from users with that, I get that. And that union will succeed. Now you could brute force this. Like if you have an injectable script, and you do a bunch of different kinds of unions with a bunch of different parameters, and you see a whole bunch of them fail, but when you get the right number, it actually does something, then you'll know the number of columns for the table that you're injecting into. So that gives you some information. Okay. So here's how we're going to use it. Exact same application. I'm going to post as a username I'm going to break syntax again. My username is 1, and then I'm going to do a union select of 1, 1, 1, 1, and then I'm going to use the hashtag to get rid of the rest of the SQL statement, the password part. And then I'm going to say my password I'm going to supply is the integer 1. And what this does is that this is the select statement that you get. And if you look at this, I have broken syntax here, I've added the union, and I've added the hashtag, which means the rest of this stuff doesn't get executed. So the first thing, when the backend database gets this query, it's going to first form the union table. So in this case, it's going to insert a row of 1s, and it's going to attach that to the table. So now we have this. And then what it's going to do is it's going to do the select password and isadmin from users, which is what that is, where username, and if you look, I cleverly chose the username to be 1, and that is the username that I am injecting over here in the select 1111. And so the username is going to be 1, and that's going to get you this row. And the result is that I am going to return that this particular user has a password of 1 and is an admin, assuming that isadmin is 1 or 0 based on the level. So I have passed back a row that's got the password of 1, that is isadmin is 1, and of course when I go and I look between what was supplied as a password and what is returned, the passwords match. So now the login is successful and I have admin privileges on this particular exploit. Okay, so you can get really creative. As soon as you're monkeying around with queries on the backend database, as soon as you have some access to the SQL commands, you can do this kind of stuff. And the world is open to you if you're good at SQL. I'm not good at SQL, so I can only show you the basics. But yeah, you can. People who have taken, 486 could probably do a lot more than just that. Okay. Another thing that is useful for SQL injection is the order by predicate. So you say order by and give it a column number, and it will sort the results based on that column. Okay, so this is useful if you want to figure out the number of columns that a table has. Because if you say order by 10, column 10, and there's only 9 columns, that query is going to fail, right? So it's similar to the union, where you need the you're trying to figure out the exact number of columns to do the union on. The order by will allow you to quickly figure out how many columns you're injecting into. You can directly inject the order by thing into your SQL statement. So if I injected into my SQL injection this order by 3, this is going to work, right? Because there are 4 columns, and the third column, I can just order by the password. That's fine. If I do order by 4, that's going to work. But as soon as I do order by 5 in my injection, that query will fail, and then I know that there are 4 columns. And then what I would do after I find this out, then I could do the union 1111, because I know there are 4 columns. So again, it's just a way of poking the backend SQL table to figure out the number of columns that it has. Another really useful thing, and there's one lab that allows you to do this. Every SQL database has this special table that basically has all the information you would ever want on that backend database. It's called information schema. And so it's not only in MySQL, it's in Postgres as well. Different databases have different specially named tables. You can just look it up per database that you're trying to get into. But this is basically data about every single table and every single column that's stored in the backend database. So information schema.tables, this is a global table that holds all the names of the tables in that backend database. If you get a particular table name, then information schema.columns is a table that contains all the different columns for a particular for the tables. Okay, so this is a way of scanning the backend database for interesting things. Is the idea. So here's an example. I don't know if this is an actual link this might be actually a demo. This is an injectable PHP script, and it's accessing a table that has, in this case, 3 columns. And what you're going to do is you're going to use this vulnerable web application to basically pull out the data from everything in the back end. All of the interesting data from the back end from this one vulnerable script. Now, the vulnerable script might be accessing a table that you're not interested in, but you can use that as a platform to get the other stuff. So that's what we're going to do it. So let's assume this query uses 5 as an input and then returns 3 columns. Then if I send this as my query, so again, I send in 5, I break the syntax, and then in the SQL interpreter, I say union select, and I know that there are 3 columns in the table that I'm injecting into, so I want the table name, table name, table name, so this will give me 3 table names. It's sort of like select 111. Select table name, table name, table name, a table name from information schema.tables, and then what this is going to send me back is a list of all the tables in the backend database, which is not really what you want. You have a question or stretching? All right. So then, okay, I have the table names, but in order to get interesting information out of those tables, I need their columns. So then you can do, hey, I'm going to select, in a subsequent query, I'm going to select column name, column name, column name from this information schema columns where the table name, so say this query, there was a table called user accounts that was returned, and I'm really interested in the user accounts table. So then I want the columns in the user accounts table. Well, this query will then get me the columns because I have the predicate that I'm interested in the table name for the table name called user accounts. So I pull this from the previous result, and then I am able to get the columns from there. And then once I have the columns, let's say the columns have both a username field and a password field. Then I can go and do another query that selects the username, password, and password from those user account tables to get the rest of it. Okay. So are there any questions about what this thing is doing? Okay. I am going to finish with non-SQL injections that are still database injections. So most everything that we covered with SQL is for relational databases, but we are quickly moving away from SQL and SQL strings into other kinds of ways of implementing backends. And so one of the more popular ways were this move towards NoSQL databases, and MongoDB was a poster child for poorly designed, poorly secured NoSQL backend databases that are everywhere now. So there is there's a couple of levels in which we will exploit MongoDB. But the thing with MongoDB is it's got different syntax, but the injection is basically the same. So that's what we're going to cover. The strategy is the same. Break the syntax, inject an always true condition, and then process the results. Okay? So the differences between SQL injection, the logical OR. Instead of in MySQL, it's the keyword OR. With MongoDB, it's the double vertical. It's more like a programming language way of doing it. And then instead of the equality check being a single equal sign, in MongoDB it's a double equal. And then instead of the comment being the pound sign or the dash dash, it's the double slash. Okay? And this is a specific instance of MongoDB, but any sort of backend database has its own language. And so the idea is just the injection is still the same, it's just different syntax, the methodology. Another thing that's happening in modern backends is a move towards database middleware. It's really painful to have to construct SQL statements for everything that your app needs to do, and it gets kind of tedious. So people are using things like object relational mapping in order to insert an object from a programming language front end. So if your web app is implemented in Python and you have an object that's basically representing a user, it's becoming common for you to just say, you know what, write this as a row into the database. So you have an object in your programming language, you want to turn it into a row in the database directly. This is what object relational mapping is doing. And the canonical example of this is SQL alchemy. So rather than accessing your backend database with SQL statements, you just say, here's my object. Every attribute is a column in my backend table. And then I just say insert. So it's object.insert, and then it will actually do the backend for you. Okay? So then you're not actually able to inject SQL. So not vulnerable to SQL injection, but still vulnerable to other things, which we'll talk about next. Another example is Ruby with their active record. Again, this is abstracting away SQL, right? It's trying to move away from SQL. Okay. But one of the things that happens is that if you take data directly from the user, create an object for that user, and send it back to the backend without sanitization, you might not be injecting SQL, but you're injecting something, right? Like based on what the backend does. And so if you are doing what's called mass assignment, where you're taking user input, forming an object, and just blindly injecting it into the backend, you can be vulnerable to attack, a database attack rather than a code attack. So here's an example. You have a user table. It's got 3 fields. Again, username, password, and whether or not the user is an admin. And so this is what the backend for the admin user looks like. And then you have a web form, and the web form only has entries for username and password. It would not have the isAdmin form because it would be like, who is going to register as an admin? I would never allow that. And so what I do is I like, okay, the only 2 attributes I care about for this user are the username and password. And so the web application creates the object based on those fields and then just inserts it directly into the backend and sets the backend so that the isAdmin by default is set to false and then is done. Okay? The problem is in the form, you can only submit username and password. But if you have somebody with Postman or Burp or something like that, if you have someone that says, oh, I'm going to set this isAdmin to true, then the default no longer holds, and then I can insert an admin user directly because you have directly mapped the object into your backend database. So that is the mass assignment exploit, where you're not validating the form fields. You're just assuming, because it doesn't exist in the form field, that you can just instantiate it on the back end. Okay. So there will be one level which you do that. Okay. So SQL injection prevention, there is a whole cheat sheet. I wouldn't necessarily go... So I wouldn't learn too much about SQL injection until you get into the real workforce and then see legacy SQL injection, or legacy SQL being done on the back end. Then you would definitely want to brush up on this. I don't know of a lot of people doing SQL backend stuff like this, but these are the techniques. Sanitizing the inputs, so never trusting user input. That's just a rule of thumb for everything. You can do a blacklist of terms. So a blacklist-based validation means you filter all of the characters that might be interpreted as a SQL command. So maybe select. You just get rid of select. From all the user input. You could do a whitelist input validation where only specific characters are allowed in the input. So maybe I get rid of the spaces so that if you're doing an injection, you can't use any spaces in your injection. Another thing is to encode all user input before passing it to SQL. Again, we have these encoding libraries that will make the string safe before you include it in a SQL statement. The other thing is to always validate on the server. Never validate only on the client and then assume that it will be okay on the server. And the reason why you would always validate on the server, and I think you have done this with your exercises, if you only do it on the client, where you're filtering, for example, here's a phone number that you're filtering. So if you do it on the client, that's fine. It'll get rid of most of the browser-based insertions of bad data. So here you have some JavaScript checking for a phone number that allows it. And if somebody does an injection, then the JavaScript will basically catch that. But the issue is if you have a proxy like Burp or Postman, you're basically going to allow this on the front end, and then the proxy is going to insert it on the back end. So this is why all of the checks, you would want to make sure that these are server side. Yeah. Yeah, so the front-end JavaScript can be easily tampered with as well, yeah. I just prefer the man in the middle. Well, actually, yeah. Sometimes you obviously have to inject it while it's in the clear. You have to do this while it's in the clear. But yeah, having a proxy is helpful in that regard. Okay, so in general, all of the application security stuff has to be done server-side. You could put it on the client as a speed-up thing. So maybe the UI can catch all the dumb stuff quickly, but in order to really enforce a policy, you have to enforce it where it matters the most, and that's on the server. Okay, another way to address this is to use what's known as prepared statements. And the prepared statement is a pre-interpreted query routine where you basically specify. So rather than taking these two parameters and injecting it into a string that represents the query that you're going to send back, rather than do that, which is vulnerable, you're going to use what's known as a prepared statement. And in the prepared statement, you have this compiled string that has the sort of two fields in this case that are denoted with the question marks. And then as part of you determining the parameters, you inject the new name and the ID, and these are fully interpreted as those field names. So there is no misinterpretation by the SQL, because the SQL knows all the SQL parts of this have been predefined. So it's impossible to inject more SQL in with these parameters, because this is a prepared, as it says, is a prepared statement. Okay. This is similar to Python F strings, if you've seen the F string usage in my Python scripts, where you're saying, here is my string template, and then just fill these two parts in with the two parameters I'm giving you. In terms of syntax, it's similar, yeah. Mm-hmm. So if the encoding library is done right, then there is no way for an attacker to inject something that will be interpreted as code. Because you need the control characters to break out of the syntax, and if you have properly filtered out those things, so it's similar to when we get to cross-site scripting, like the script tags, the tags in HTML are the greater than and the less than. If you make sure that you turn all those things into the HTML encoding code word, then the backend will treat that as data regardless. But if you allow that special character in that can escape the syntax, that's where your issue is. So yeah, if there have been attempts at filtering that have failed, which is why you have a couple of levels where bad filtering can be bypassed. MySQL, no, it was PHP. PHP had, there's the history of their PHP MySQL escape string, which was a library for escaping out strings so that the MySQL the MySQL backend couldn't be injected. They had to go through multiple iterations of that because people were finding ways of bypassing the encoding scheme. And then this is why you would always want to use an encoding scheme that has been vetted, right? Don't roll your own filtering scheme unless you're doing something that no library exists for that particular filtering, is what you would recommend. Okay, another thing that's used is Parameterize Queries, which is very similar to the prepared statement. So you set up your query and you select the parameters that you want to have filled in. So in this case, this is the query that I'm running, and everything is static except for these two strings. And again, this is very similar to the format string, two strings, and then I am going to specify those things as higher start and higher end. So I'm going to execute that query template string with these two as a tuple sent in to fill in, so higher start and higher end, which was created here. I'm going to fill those two things into these two parts of the query statement. So yeah, all of your database backend code should look like that if you see it in SQL. Okay, and then hopefully SQL injection will not have to be covered in this class anymore. So the labs, there is the Web for Pentester 1 SQL injection examples and the Web for Pentester 2. And so these are meant to be quick. So again, information sharing on these labs are encouraged. And then there is a MongoDB example and a mass assignment example for you to look at. Okay. The homework. There are the first 6 injection levels are the homework. So these are the levels. I have some notes on the ones that require some, I guess, some more support for you to solve. The first one is injection 5. It's an obfuscated JavaScript. And so that's the site that I would recommend. Hopefully it still works. There's a JS deobfuscator that will show you what that JavaScript is doing. One of the things is part of exploitation of this level is that you'll get back a coupon code with an HTML coded slash in it. This is what it looks like. And so when you are trying to redeem this coupon code, you don't paste this in, you paste in the slash. Like the output you get back is HTML encoded, but then that is meant to be sort of interpreted as a slash and then sent in as the coupon code. That has really hung people up on this particular level. The injection escaping, one of the things that gets passed back is a backslash. And so if the backslash is the escape character, this will turn into a backslash single quote. A quote turns into a backslash single quote, in which case you want it to, if that is your output that you get back, you want to strip out the backslash in order to get that one to work. So these are the two hints that will hopefully get you to this solution. Okay. And then this is a Python script for solving the SQL injection lesson. And you can see if you run this on the SQL injection script, you can basically reverse engineer the SQL script, the form submission, and then you can see that this is a script that will solve this automatically. And this will hopefully get you started on the SQL injection levels, sort of how they're built. But I'm not going to go through that. So I'm going to stop here. Are there any questions about SQL or injection? So yeah, you have about 25 minutes to start on the levels. So I'll end.